So this is exercise 27 that someone did in class on Monday. I'm going to redo this very slowly to show you how you find the relative mean, relative max, and also where it's increasing, where it's decreasing for this function. I have actually drawn the table, so you shouldn't be drawing the table in advance, especially the vertical lines, because you do not know how many vertical lines there will be. Now, how do you find the vertical lines? You find all the critical numbers, and where the function is not defined. So this is a polynomial, so it's defined everywhere. The derivative of this function is given by minus 21x squared plus 21. And if you are to factor out negative 21, you will get x squared minus 1. But x squared minus 1 is again factorable, so I'm going to write that as x minus 1, x plus 1. So very clearly we know the two critical numbers are 1 and negative 1. Those numbers that makes those two factors 0. So I will put them in order. I would have to put my negative 1 here and put my 1 here. The domain of this function is negative infinity and infinity. So we know the interval that we have to concentrate on this table is given by that, thanks to those numbers on the top of the rectangle. Okay, so very naturally we write out our interval. The test values are values we choose inside the interval. You can choose any number you want, but we always choose the most convenient one. Say suppose you like negative 2 for this, and here you can choose a 1, 0.5, or you can choose 0, which is so much easier, or even negative half. That's good. You can choose a 2 here, you can choose a 3 here. It really doesn't matter. Okay, and then come the crucial part. The crucial part is, which is what I really didn't show most of the time, but I'm going to show it very slowly now. I don't have much space to do scratch work. But you see, say suppose we want to know the sign for the number 3. That means actually not just for the number 3. It is valid for every number between 1 and infinity. So I pick 3, and when I put a 3 inside here, I get 3 minus 1. That's a 2. Oops, sorry. That's a 2. And then 3 plus 1 is a 4. And then there's a negative 21. If you multiply these three numbers together, do you get a positive or negative number? Negative, so you put negative. Negative. Likewise, if you put a 0 inside, if I put a 0 inside, I will get again negative 21. 0 minus 1 is negative 1. 0 plus 1 is 1. So this is positive 21, isn't it? Positive 21. So is that positive or negative? Positive. If you're not sure, you're allowed to put a number here. Yeah, you know it's positive 21. Yeah. If I put a negative 2 inside, what would I get? If I put a negative 2 inside, again I get a negative 21 here. And negative 2, negative 1 is negative 3. Negative 2 plus 1 is a negative 1. If you multiply all these three together, what do you get? A positive 63. It's a positive 63. And so, wait a minute, sorry, it's negative 63. Did I say it wrong? Negative 21, negative 3, negative 1, positive 60, negative 63. So I got this slightly wrong. Negative 63. So this is actually negative. Now, using the theorem, we know when the first derivative is negative, the function is decreasing. And when the first derivative is positive, the function is increasing. When the first derivative is negative, the function is decreasing. So now we know this function will be decreasing from here to here. Oops, I shouldn't be using that line. decreasing from here to here, right? And increasing from -1 to 1, and decreasing again from 1 all the way to infinity. So this is the general shape of the curve. You will probably be able to tell that at -1, you get a relative minimum, and at 1, you get a relative maximum.